There's got to be something out there that is possibly shepherding the orbits into a particular direction. There might actually be the ninth planet in our solar system. There is a ninth planet in our solar system, and it's not Pluto. NASA has made a remarkable discovery in the vast expanse of our solar system. A ninth planet lurking beyond the familiar orbits of Neptune and Pluto has been unveiled. However, there is a sinister aspect to this astronomical discovery, a riddle that has left experts perplexed and the public fascinated. Something strange is happening on Planet 9, an anomaly unlike anything seen before in our cosmic neighborhood. Could it be evidence of alien interference, a cosmic collision, or something completely different that we don't understand? Join us as we explore how NASA discovered a ninth planet in our solar system, but something strange is happening. Our planet Earth is part of a solar system that consists of 8 planets orbiting a massive blazing star we call the Sun. For thousands of years, astronomers studying the solar system have noticed that these planets march across the sky in a predictable way. Some are moving forward at a faster rate than others, and some even appear to be going backward according to their observations. However, we're getting ahead of ourselves. Let's go back to how this solar system started. The solar nebula, a huge cloud of gas and dust, started to take form around 4.6 billion years ago, giving rise to the early solar system. An outside force, perhaps a nearby supernova, caused the nebula to collapse under the pull of gravity and begin spinning. As a result of the principle of conservation of angular momentum, a protostar gradually emerged at the core of the rotating cloud, which eventually became hotter and denser. The process of accretion caused tiny dust grains to collide and cluster into bigger things known as planetesimals. When the surrounding material started to bind together, protoplanets were formed, which eventually increased in mass and size as they continued to absorb more and more stuff. The Sun likewise increased in size and brightness during this period. After surpassing the combined mass of the planets, asteroids, and comets, it emerged as the solar system's most powerful object. Denser material sank to the protoplanets' cores, and lighter ones rose to their surfaces as their innards grew hotter and more differentiated. As they continued to collect material, the planets with rocky surfaces formed as a result of this process. Up to a point, the Sun's powerful rays and solar wind blew away the last of the gas and dust. Out in space, where temperatures were lower, gas and ice could stay gaseous, leading to the creation of gas giants such as Saturn and Jupiter. Beyond that, the cold planets Neptune and Uranus got their atmospheres and icy mantles. Even though every planet in our solar system is special in its own way, there are some similarities among them. For example, every planet has a north and a south pole. These points are in the center of the planet at its ends. Another feature that distinguishes our solar system from the outer solar system is the major asteroid belt, which extends from Jupiter to Mars. Even though when most people think of our solar system, they picture the Sun, planets, and Earth, there are actually a lot of different kinds of bodies that form a ring around the Sun: comets, meteors, asteroids, moons, and some moons have moons of their own. Space dust and the hotly contested dwarf planets are among these other heavenly bodies. Back in 2005, scientists discovered a far-flung body of rock and ice that they later called Eris. The fact that it was further from the Sun and bigger than Pluto raised philosophical concerns about the definition of a planet. Was Eris the 10th planet in our solar system? If not, why could Pluto be a planet but Eris couldn't? In 2006, the International Astronomical Union (IAU) determined that an object must meet the following criteria in order to qualify as a planet. It has to orbit the Sun directly. That means Earth's moon doesn't count because it orbits our planet, not the Sun. It has to be large enough to be spherical in shape due to its own gravity, and it must have cleared its neighborhood, meaning that it's the dominant object in its orbit. For the latter, we can thank the demotion of Pluto from the 9th planet to the dwarf planet status, joining Eris, Makemake, Haumea, and Orcus. Ever since Pluto was kicked out of the club, there has been some indication that there might be one more planet in the solar system, bringing the total number of known planets to 9 again. A hypothetical planet 9 lurking on the outer edge of our solar system. So far, this world has eluded discovery, but a new study has pinned down where it should be. Planet 9's gravitational pull on other bodies provides evidence of its existence. Assuming the planet is real, its gravitational pull will change the paths of other celestial bodies. Doing some simple math will reveal the source of any apparent gravitational pull on a planet. The discovery of Neptune came about after two astronomers, John Couch Adams and Urbain Le Verrier, separately noted that an invisible planet appeared to be pulling on Uranus. When it comes to Planet 9, our gravitational pull has no bearing on it. We do observe a peculiar assembly of tiny icy objects called Kuiper Belt objects, KBOs, located in the solar system's outer regions. If the Kuiper Belt was empty of planets, the KBO's orbits would appear to be randomly oriented within the solar system's orbital plane. The opposite is true, though. A large number of KBO orbits tend to cluster together. It's possible that this is just due to random chance, but that isn't likely. In 2016, the authors determined that an undetected outer planet was the origin of the clustering by looking at the statistical distribution of KBOs. Their estimates put its mass at 5 Earths and its distance from the Sun at around 10 times that of Neptune. A wide area of the sky that could contain the planet was even estimated in the article, but no results were found in the searches. Some came to the conclusion that Earth doesn't exist because of these strange orbits. Do not indicate the existence of planets. Planet Vulcan will tell you. In view of some of the criticisms leveled against the original work, this new study revisits it. The fact that bodies in the outer solar system are hard to spot, leading us to search in inconvenient places, is a major point of criticism. Our observation of a clustering effect may simply be the result of biased data. Despite accounting for observational bias, the authors conclude that the clustering remains statistically significant. There's a very small probability that it's just a coincidence. They improve their targeting by recalculating the probable orbit of Planet 9. The study's intriguing new orbit brings Planet 9 closer to the Sun than earlier estimates. Some have even gone as far as to say that Planet 9 is real, but that because it is a primordial black hole, we will never be able to see it. Might it not be a planet at all? Could it be a primordial black hole? Even though our astronomy methods are getting better all the time, there are still a lot of little worlds in the outer solar system that have remained undiscovered. The 9th planet in our solar system is believed to be much larger than Earth, with a mass of 5 to 10 Earth masses, and it orbits the Sun at an average distance of 400 to 800 astronomical units. The average distance that Earth orbits the Sun is 1 astronomical unit, which is 10 to 20 times farther than Pluto's orbit. If there is a Planet 9, its one orbit would take 10,000 to 20,000 years. The possibility of a large world orbiting the Sun at such a huge distance is captivating. Studies of other star systems reveal that exoplanets between the masses of Earth and Neptune are relatively common. Why our solar system doesn't contain a world within this mass range is a puzzle, but if Planet 9 really is out there, it would be a profound historic discovery that would reshape our understanding of the system of planets that orbit our Sun. It goes without saying that a planet with such an eccentric orbit would be extremely elusive, yet scientists continue to scour infrared surveys in the hopes of spotting a faraway object creeping across the sky. Apart from the gravitational pull of an object in the outer solar system, there's very little direct evidence for the existence of Planet 9. If it is out there, it should be producing infrared radiation, which is energy that has leaked from the planet since its birth. Now we reach the black hole hypothesis. In a new study, astronomers Jacob Schultz of Durham University and James Onwin of the University of Illinois at Chicago presented their competing theory that the gravitational anomalies in the solar system's furthest regions are not generated by planets at all. Instead, they pointed to the presence of a primordial black hole, a theory that has caused a bit of a stir. Now, this kind of black hole doesn't pose a danger to the rest of the solar system, as it would simply be too small. But in the distant regions of our solar system, its impact would be significant. The only evidence we have for Planet 9's existence is the gravitational effects it's having on TNOs, and black holes are the most gravitationally endowed objects in the universe, after all. Primordial black holes are the most ancient kind of black hole that are hypothesized to have formed right after the Big Bang. Black holes of varying masses would have been quickly created in the early cosmos due to changes in density. After being scattered over space, these long-gone items would have gradually faded away due to Hawking radiation, with smaller ones appearing first. Although there is strong indirect evidence for their existence, no direct observation of a primordial black hole has been made, despite the fact that several models of cosmic evolution propose their existence. Consider microlensing events when a massive object briefly brightens stars as it passes in front of them due to the curvature of spacetime acting as a magnifying lens. These events imply that there may be a population of tiny black holes in the universe that can only be detected by their gravitational effects on spacetime. With a new perspective on the TNO anomalies, Schultz and Unwind predicted the consequence of an extremely elliptical sun-orbiting black hole with a mass of 5 to 10 Earth masses. Indeed, according to their models, the population of TNOs would experience comparable orbital disturbances if a primordial black hole had a mass in this range. Because a primordial black hole wouldn't produce either an optical or infrared signal, this may also explain the paucity of evidence for Planet 9. Actually, a black hole in the area may be destroying dark matter and producing various radiations by pulling a cloud of dark matter with it. In light of these results, the researchers propose an enlarged experimental program to seek out mobile sources of high-energy cosmic rays, such as X-rays, gamma rays, and other such radiation. The substitution of a made-up planet for a made-up black hole type runs the risk of adding unnecessary complexity to the riddle of Planet 9. But this is an intriguing line of inquiry. Could a black hole explain the gravitational effects we are seeing in the outer solar system? Absolutely. All we know is that there is a sizable mass something out there, and we don't know what the something is. Some individuals find solace in apocalyptic predictions, even though they are often met with open minds. Many popular notions about the end times are based on flawed science and completely unsubstantiated evidence. Consider the Nibiru cataclysm, one of the most egregious examples of the end-of-the-world scenario. According to the majority of believers, Nibiru is a mysterious planet that circles the Sun, returning to its original orbit every 3,600 Earth years. Nibiru, also known as Planet X or Planet 9, is a giant planet tracing a collision course with us, supposedly headed for a catastrophic collision or, failing that, a chain reaction of natural disasters that will wipe out human civilization. Nibiru entered the public consciousness in 1976 with the publication of The 12th Planet by Zecharia Sitchin. We should note that Sitchin himself didn't believe Nibiru posed any immediate threat to mankind. On the contrary, he thought it was linked to the creation of our species. Yeah, there's a lot to unpack here. The late Sitchin was a journalist and a student of Sumerian cuneiform, ancient writings of Mesopotamia and Persia, mainly on clay tablets. Somewhere down the line, he became convinced that Homo sapiens are not the product of natural selection, at least not entirely. According to his questionable interpretations of ancient Mesopotamian texts and inscriptions, the first humans were bioengineered by some aliens called the Anunnaki, who once colonized southeastern Africa. These extraterrestrials, according to Sitchin, were from the as-yet undiscovered planet Nibiru, which he said would circle Earth every 3,600 years before vanishing into space. In the case of Nibiru, it was inevitable that it would become a source of terror. Beginning in the mid-1990s, numerous doomsday and conspiracy theories included the fictional Nibiru. One psychic even went so far as to foretell that Nibiru would pass Earth in 2003, wreaking havoc along the way. Clearly, this was not to be, but Nibiru continued to make headlines. Some Christian fundamentalists in 2017 claimed that Nibiru, or a comparable object, was rapidly approaching and would soon announce the end of the world, which was a belief held by many who supported the false 2012 apocalypse. Nibiru is said to have an orbital period of 3,600 Earth years. At first glance, this seems reasonable enough, considering that one orbit of the minor planet Sedna, which does in fact exist, takes an incredible 11,000 or 12,400 Earth years to complete. However, Sedna gives the Sun a wide berth. Astronomers and planetary scientists use astronomical units to measure some of the vast distances in the universe. One astronomical unit is equal to about 93 million miles, which is the average distance between Earth and the Sun. By the time it reaches its apogee, Sedna will be 76 astronomical units from the Sun, placing it in the outer solar system, far beyond Uranus, Neptune, and Pluto. The much-maligned 9th planet, on the other hand, Nibiru, is expected to make regular forays into the inner solar system, where Mercury, Venus, Earth, and Mars are located. Based on these parameters, it was determined that the farthest point of Nibiru's orbit would be approximately 469 astronomical units from the Sun. Thus, in 3,600 years, Poor Nibiru would have to travel the entire distance from Earth to this extremely faraway spot and back again to remain on schedule. The planet would require an absurdly narrow, nearly stick-shaped orbit rather than a circular one. On top of that, Nibiru would be traveling at a dizzying 26.1 miles per second as it passed Earth. This is obviously not good news because a planet cruising along an unstable orbit at such a high velocity runs the risk of being ejected from the solar system altogether. What would happen if Nibiru remained in its current bizarre orbit around the Sun? We would have found obvious signs of that by now. According to NASA's Planetary Science Division, it was in 1992 that astronomers, who had doggedly scanned the heavens in search of dim objects beyond Neptune, discovered the distant Kuiper belt, which is thought to contain hundreds of thousands of other objects, as well as smaller objects discovered such as up to 1 trillion distant comets and 3 dwarf planets. Haumea, Makemake, and Eris. What other hypothetical planets could be lurking in our own solar system that we don't know about? Long before Neptune was found in 1846, astronomers had a hunch that a large planet might be in the area. This was due to the fact that astronomers had noted that Uranus, which had been seen for the first time in 1781, continued to stray from its predicted orbit. Mathematicians had speculated that this might be due to an influence from a nearby planet, and sure enough, their predictions were correct. The unknown planet was later proved to be the gas giant Neptune. Similarly, if Nibiru were to exist, its impact on the other planets in our solar system would be readily apparent. And if, as many apologists assert, Nibiru were a large planet, the gravitational pull of such a world would be far more pronounced. The present-day planetary orbits of all the planets from Venus to Neptune are mostly on the same plane with respect to the Sun, within a few degrees of variation. However, planetary scientist David Morrison has shown that if a body similar to Nibiru were hurtling past Earth every 3,600 years, its gravity would have pushed at least some of these planets far from the plane, resulting in drastically skewed orbital paths. Lastly, there is the matter of direct observation, or rather the absence of it. Nibiru would have been detected by astronomers years before it reached Earth. A few months before the errant planet arrived, it would have shone brighter than some stars that are now visible to the human eye. However, no one has ever seen the prophesied planet, not even amateur astronomers, and there is no scientific evidence to suggest that anyone ever will. Anyway, scientists have yet to figure out Planet 9's precise location, so it may take a while for someone to observe it with a telescope.